And so we're going to just fill out this table. This is the only time we're going to do it. We're just going to talk about the very basic parabola. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And negative 1 squared is also 1, 4, and 9. So we can plot these points. 0, 0, 1, 1, negative 1, 1, 2, 3, 4. You can plot these points. And most of you are familiar with this shape already. 4, 5, 6, 7, 8, 9. And so you can connect this with a smooth curve, and that is your parabola. Some things to notice. This right here is called the vertex. Could be a max or a min. In this case it's a minimum because that's the lowest it gets. And it's very important because if it's upside down, if the parabola is upside down, that's the highest point something reaches. You know when it reaches it, you know how high it reaches. Axis of symmetry. Parabolas are symmetric. And so right down the middle, it has this axis of symmetry. Meaning that every point on this side is reflected. Every point on this side has a point on this side. Every point on this side, so on. And so the minimum and the maximum, like we talked about as well. Domain and range. The domain has to do with the x's. And so it's the numbers we are allowed to plug in. We can plug in any single number we want. And so we say all real numbers. We can also use this symbol, kind of looks like the paragraph symbol. All real numbers. The range, however, on this one, you don't get any negative numbers out because we've squared everything and made it positive, and so the range is all the y values that are greater than or equal to 0. So that's your range. The range will always have to do with y is greater than some point, being the vertex, or always being less than some point if it opens upside down. So, I don't want to make a table for every single graph. Math is all about looking at patterns, and so that's what we're going to be doing rather than taking our time up with making tables every single time. So I'm graphing the original, the one we just did. Remember, 1 squared, 2 squared is 4, 3 squared is 9. If you know that, you're going to be in really good shape. Because everything is going to be relative to that. We're going to be adapting it. So this is the A. Y equals negative x squared. If you square everything and then make it negative, it's going to flip it upside down. And so B is going to be the exact opposite, but upside down. So that's what this one looks like. So anytime you stick a negative in front, flips it over the x-axis. A negative in front. Reflects over x. Alright, 3x squared. After you square it, then multiply it by 3. What that's going to do is stretch it out vertically because 1 squared and then times 3. So it's not actually going to 1, it's going to 3. 2 squared is 4. It's not actually going to 4, it's going to 4 times the 3. So it's going to 12. 10, 11, 12. And it's reflected the same way on the other side. Negative 1 squared is 1, but times 3. Negative 2 squared is 4 times 3. And so it stretches it out vertically. And so that's C. 1/4 x squared, obviously it's going to have the opposite effect of the 3. It's going to make it shorter. And so that's our B. 1/4, it's only going to be if it multiplied by 1 and then multiplied by 1/4. Sorry, 1 squared is 1. And so then if 2 squared is 4, 4 times 1/4 is 1 again. And so you're right there. See how it's going, kicking out wider, and so it does the same thing on the opposite side because it's symmetric. And then I'm going to go out to 4 squared because it's a prettier number than 9. 4 squared is 16 times 1/4. 1, 2, 3, 4. 1, 2, 3, 4. 16 times 1/4 is 4. And so it looks like that. And you get the idea. And so that's how the basic graphs work, where you just multiply by a constant out front. Now,